We're going to talk today about how many solutions an equation can have. So remember, an equation is a statement that proves that two expressions have an equal value. So we're going to start out with this first one. So we have 4x equals 2x plus 6. So remember, when we go to solve, we're going to go ahead and try to isolate the variable. So we'll put our little while there. We want to get our variables on one side. So I have a 4x over on the left and a 2x on the right. So I'm going to move that 2x over by subtracting. So on this side, it's now gone from this side. I'm only left with a 6. And here I have a 4x minus 2x. I have 2x. So now that I have my numbers by themselves and my variable by itself, I need to then get the coefficient away. So I divide by my coefficient of 2 on both sides. 2 divided by 2 is 1. That's why I'm left with just 1x. And 6 divided by 2 is 3. So in this case, I have a one solution. I have one solution, and this tells me that anytime in this problem, x is going to equal 3. Only one number is going to work. So we have to think about, if we put in a 3 for the x on the left side, we have to put in a 3 for the x on the right side. We can't put in different numbers. One solution works. So let's look at this next one. We have 1x plus 10 equals 1x plus 20. So if I isolate my variables, and I'm going ahead and moving over my variables to my wall, so I want to get my variables to one side, minus 1x minus 1x. Notice what happens to my variables. They're gone from both sides. I have no x's on either side, but I have 10 equals 20. Well, that's not a true statement. 10 can never equal 20. 20 can never equal 10. So this is a no solution. So a no solution, we would put as a big 0 with a slash through it to represent no solution as well. These variables have canceled out. Now, if we didn't move variables first and we moved the numbers, you would still see that they would cancel out and that you would have nothing. I always like to move my variables first, but the variables canceled. The statement is not true because 10 cannot equal 20. Now, let's look at the third example. We have 1x plus 4 equals 1x plus 4. Well, this should be pretty evident just by looking at it. I have a 1x here on the left side and 1x on the right side, and I have a 4 and a 4, and they're both positive. Well, 1x plus 4, that's like looking in a mirror. It equals 1x plus 4. So this is a true statement. The variables can cancel out, but the statement's true. So if I move my variables, and I don't see it at first, these cancel out, but I get 4 equals 4. Well, that's a true statement. This is true. So this is an all solutions. So we can have, and we use an infinity sign for that, we can have one solution where only one variable, one number will work. We can have no solutions where it doesn't work. It's never going to work no matter what we do. Never balance. Or we can have all solutions, meaning we could put any number in for x, it would work. So if I put in a 4 right here and right here, because x has to be 4 on both, 1 times 4 is 4, 4 plus 4 is 8. Same thing over here, 4 times 1 is 4 plus 4 is 8. It's true. I could put in a decimal, I could put in a negative number, whatever. Any solution is going to work. So that's an all solution. So we can have 3 different types, one solution, no solution, and infinitely many solutions, or what we consider all solutions. So let's look at some of these examples and determine whether they're one solution, all solutions, or no solutions. So example A, when n equals n. Well, it's like looking in a mirror. So yes, this is an all solution. We could put in a 3, and for both of them, they would equal 3. So this is an all solution. Or you can use the infinity sign. So I'm terrible at drawing. All right, so let's look at this one. Now, don't just assume, oh, I see a 3n plus 1 and a 3n plus 1. This is distributing. This is actually going to be 3n plus 3 equals 3n plus 1. Now you can see they're not identical. But when I move my 3n over, I'm going to end up seeing they both cancel out, and I get 3 equals 1. Well, that's not a true statement, so this is a no solution. All right, let's look at example C. Now, before we start moving things over to try to solve, remember we always want to combine like terms. Well, I have a positive 5 and a negative 9, so I actually have negative 4 plus 3x. And here I have a negative 10 plus a 6, so I have a negative 4 plus 3x. If you do that first, you'll realize, oh, they're exactly the same. So this is an all solution for our little infinity sign. Any number will work for our variable there. All right, let's look at example D. It's kind of written a little weird, but we want to simplify before we start working. So this is y times negative 6 times negative 3. Well, let's multiply our numbers here and get those together. So we have a negative 6 and a negative 3, which is 18, a positive 18. And it's being multiplied times y, so that's 18y. And then we have a 2 and a 9. Well, 2 times 9 is 18 times the y, 18y. So this we can see is identical. So this is an all solution as well, or infinite symbol. Ooh, that one's terrible. An infinite symbol there. All right, let's look at our next one, example E. 2x plus 6 on one side, and we have bubbles, so we need to distribute 2x plus 6, 2x plus 6. We see these are identical. If you don't see immediately they're identical, when you start to move things over and combine things together, you end up with the variables canceling, but 6 equals 6 is a true statement. So this is all real numbers. This is an all solutions, infinitely many. All right, let's look at F. We have a fraction here. Now we can use our clearing fractions, or this one's a pretty simple one we can go ahead and distribute. 1/4 times 20. Remember, it's just like saying 20 times the 1 over 4, which gives you 5d. Okay? And then 1/4 times 4 gives me 1. Now, I have 5d on the right side and 5d on the left side, but I have a 1 over here, so I'm going to move this 5d over. And I end up with 1 equals nothing. Because 5d minus 5d is nothing, no d's. So 1 does not equal 0, so that's a no solution. That's not a true statement. All right, let's look at the next one. If I look pretty quickly, I can see I have a positive x and a positive x. When they're positive on both sides, when we move one over, we know they're going to cancel out. Just like we can look at these up here. When we move things over, we know they're going to cancel out. When they're positive and positive, they're going to cancel out. So here, we know they're identical, they're going to cancel out. When we're going to be left with a half equals 1/3. Well, that's not true. So that's no real solutions or no solutions. All right. Now here we have a positive x and a positive x on either side. We know that if we move them, minus x, they're going to cancel out on each side, and we're left with 2 equals, but we have a sign in front of this 2, which is negative. Well, 2 does not equal a negative 2, so this 2 is a no solution. So remember that all solutions, all true equivalent expressions on each side will work no matter what. Sometimes you don't always see it. When it's not true, it's not a true statement, like this last one. 2 does not equal negative 2. Be very careful. Always try to think about distributing first and get down as far as you can. Don't just look at it and assume. Take the extra few minutes and make sure that you actually know.